So, did we all have food? Are we all nice and fed, ready to talk about choices? Hi, I'm Dorota. I work at Authres, which is an authentication and authorization API. So, if you're making software and you need your users to log in, or you want fine-grained permissions, instead of coding those bits yourself, you can use our tool. And our customers are software engineers, so smart people. Sometimes they come and ask, should we really pay for your tool? Maybe we can just build it ourselves. And as a founder, of course, I would love to tell them, yes, you should always use our tool, it's the best. Sometimes that's just not the right answer. I've been in the software business long enough to know that any sort of blanket statement, you should always do this, is going to be right at best some of the time. So I wanted to create a framework that will let every engineer decide for themselves what makes the most sense in their situation, to build, to buy, or to use open source. To create that framework, I looked at how different companies make such decisions, what factors they consider important, and most crucially, where they go wrong. So let's get into it. And we start with what? That's what we start with. What is that we need? What is it for? What are we talking about? And of course, the first step is for us to sit down and start listing all the requirements, all the features we need, or the details, how it will work, right? Wrong. That's the first pitfall, jumping straight to solutions. If we do that, we pretty much remove the decision there and then. Because if we list all the implementation details, we either end up with something so specific that we have no choice but to build it, or something that looks exactly like that other thing we've seen somewhere else, so we have no choice but to use that solution. A better way is to start by verbalizing the problem statement. And I say problem, not solution. So instead of saying, we need a car, say, we need to get from point A to point B. There will be time to list all the features, but that's later. And the next important thing, or useful thing to start with, is to verbalize the problem statement. Can we even talk about it? Can we explain it to people outside of our most immediate group? What are the keywords? Can we search for it on the internet? If we can't, then something is wrong. It's 2024. No idea or problem is unique. If we can't really find it on the internet, then maybe this isn't a real problem. Or maybe it's not a problem that's worth solving. Or maybe we are talking about it using words that aren't industry standard. And if we can't correctly talk about the problem, then good luck finding a solution or designing it. So it looks like we may have a prerequisite to our decision process, verbalizing the problem statement. So we have that. Do we list our features now? Let's just take a moment to briefly consider the nature of our problem. Otherwise, we'll fall into another pitfall. Many years ago, I used to work at a company with a large monolithic code base full of spaghetti code. And we were running nightly builds. So a process would come, pick up all the commits from the day, resolve all conflicts, build our modules, and even run some tests. And the tool to run all of that was entirely homegrown. A software engineer who built it was really proud of it and well respected. But by the time I joined the company, every time the nightly build failed, which was like almost every day, it was about 50-50 whether the problem was a real issue in our code base or our wonderful build tool acting up. And I spent many days cursing under my breath and thinking to myself, surely there must be a better way. We can't be the only company that does nightly builds. But the prevalent sentiment among senior engineers So people I looked up to was that our code base is unique. It is special. So we had to do it that way. Many years later, different time, different life, I was advising a late-stage startup, a scale-up really. They had a web-based product in HR space. And the CEO was really frustrated with the engineering. They had a lot of quality issues. They couldn't onboard new users as fast as they wanted. And looking at their tech stack, it turned out that the main thing, their core offering, was just a thin UI layer on top of a bunch of third-party solutions cobbled together with hacks and prayers. Talking to the senior engineers, trying to learn that story, there was one thing that everyone kept repeating like a mantra. We don't want to reinvent the wheel. Now, what both of those situations, very different situations, have in common was that the engineers didn't bother to stop and think about the nature of their problem. Instead, whatever strong beliefs they had at the time, our code base is special. We don't want to reinvent the wheel. Those beliefs dictated the solution. And the results were not the best. So, let's briefly take a look at our problem. What is the nature of the beast? Let's consider how complex is our problem space. It can be something really simple, straightforward. For example, we need to parse these strings. And notice I said parse these strings and not recursively iterate over each character, check if it matches our schema. Problems, not solutions. So it can be something simple, or it can be something complicated, where we have multiple different pieces that have to come together, but the pieces themselves are fairly straightforward. For example, we want to edit and format various text documents. Or it can be something complex, where we have different pieces that have to come together. They have relationships, non-obvious interdependencies. For example, we need to fully automate handling of our customer support emails. Now, this classification already tells us something interesting. The more complex the problem space, the more unknowns we will encounter. At the extreme, we are talking about unknown unknowns, so things we cannot possibly plan for, because we don't know these things. This means that our assumptions about what constitutes a solution are increasingly likely going to be wrong the further along this axis. Or in other words, the more complex the problem space, the less likely we can know upfront what a good solution looks like. But that's just part of the picture. Another lens we can use to look at our problem is the context. How specific is it to our situation? Are we the only ones who have this problem? So a problem can be something generic, applicable to a lot of different people, different companies. For example, we want to edit and format various text documents. Or it could be something specific to a given domain or a narrow market segment. For example, we need to edit and display our employee records. And yes, those may be our employees, but that's irrelevant. The problem is specific to an HR domain, and a lot of companies with employees will have that. Now, our problem can also be something really specific to our company, to our business model. If we are a company that makes money selling HR software, then we may say we want to enable our customers to edit and display their employee records. Notice how the last two are sort of similar, but the context really makes a big difference. So the more specific to our own context a problem is, the more familiar we will be with the space, the more nuance we will see, and more detailed requirements we will have. Or the other way, the further away from our context, the more unknowns there will be. And this is where the two companies that I told you about went wrong. They misclassified the problem. In the case of the nightly build, the engineers thought this was a company-specific problem because it's our code base, it is special. The problem was generic, or maybe domain-specific if you consider making software a domain. Now, the other company, the one with HR tool without the backend, they generalized too much. They didn't leave anything company-specific. And both were a mess. Now, it is helpful to get this somewhat right, because if we combine these two perspectives, we can roughly map the number and type of the unknowns like this. The further away from our own context and the more complex a problem space, the more unknowns we will encounter. This is represented by a darker color. This means there will be more uncertainty, the less likely we can predict how long it will take, how much it will cost, and even what kind of features we will need. And in this little corner here be dragons. There are a lot of unknowns, and most of the time we won't know about them. And this area in general is what I like to call corner of ignorance. Because there are unknowns that we don't know about. There's a large number of uncertainty, a lot of issues. And this is the place where we frequently stupid ourselves. So when faced with a lot of unknowns and uncertainty, there are two failure modes I see people fall into. One is when we realize there's uncertainty, we get uneasy, and we do what our instincts tell us to do. We try to take control. We have to do it ourselves. We can't trust anyone else. Now, the second failure mode, in my opinion, way more dangerous, is when we do not recognize the unknowns. We just assume the problem is much simpler. How hard can it be? And then we may attempt to solve it real quick. And then we run out of time, and we end up with a half solution full of bugs that some poor soul at your company has to live with. Now, if we add a touch of hubris, we can do it better. You get the not invented here syndrome. It may be fun to write your own continuous integration tool, but trust me, it's not going to be better than something that was written by people who were specifically paid to solve that problem. Okay, so just looking at the nature of a problem, we can avoid the corner of ignorance. But we can take it further. We can use this mental model to try and narrow down our decision space, to see who is in the best position to solve a given problem based on the number of the unknowns. Let's try that. For simple problems, I'm going to remove buying as an option. That's because no one likes paying for solving simple problems. There's no money to be made. Even if you manage to find a commercial solution that solves this one simple problem, it likely also has other stuff, and maybe your problem is not the main thing that they're selling, so... Now, for generic problems, I'm going to remove build as an option. That's why, because while we could theoretically build it ourselves, we're not the best people to do so, because we don't know the area. The best people who do so are the people who made it their context, for whom this is company-specific, because they will know more. In fact, I'm going to remove build from the whole corner of ignorance, the same reason. And I'm going to extend that logic to the complex company-specific problems, where we are the ones who know most. Therefore, any third party is likely not going to be able to do that, unless there are competitors, but we don't want to give money to our competitors. Now, we already have two pretty clear recommendations, and now I would love to keep removing options, but here's where things get a little bit situational. For domain-specific complicated problems, we may be able to build a good solution if the domain is something adjacent to our space, if we're familiar with it. Otherwise, it's sort of part of the corner of ignorance. So whether we can do it or not, it depends. So I'm going to add a question mark here. For company-specific, simple and complicated problems, we may be able to find external solutions that sort of fit and adapt them, adjust them, sort of hammer them into shape. But again, maybe, maybe not. So I'm adding more question marks. So just by taking a little bit of time to consider the nature of our problem, we were able to already get pretty far, pretty fast in our decision process. Speaking of fast, that's something we should talk about. How much time do we have? How much time do we have to solve this problem? Does it have to be solved now? Can we wait? If we can delay, it may be beneficial because we may get more options for solving this issue. We may learn more. Maybe even the problem itself will change. But we have to balance it with the cost of delay. If we wait too long, we may be losing money because the problem isn't solved. We may be losing opportunities. So something to keep in mind. And if we wait too long, our options will be severely limited. And sometimes that's the situation. We're in a rush. We have to solve this problem now. So what is fastest? Conventional wisdom says that it is faster to use something that already exists. Now, between open source and buying, you should always expect the commercial solution to be faster to get started with. That's the reason why is because the commercial solutions get optimized for new user onboarding. That's how they make money. Companies that don't do that eventually run and get out of business. But there's a big caveat here, because finding and selecting a solution takes time. Especially for commercial solutions, you may have to sit through a bunch of sales calls. Yay. And then even if we find a solution, then we still have to integrate it with our systems, with our processes. We need to train people to use it. And if a problem is really simple, it may be really fastest to just hack it in and be done with it. Speaking of hacking things in, this reminds me how in the early days of Authris, we had 2 different customers coming on board roughly at the same time. They were both early-stage startups, moving very fast, and they made similar decisions up until that point. They both decided to pay for a no-code platform to create their first prototype because it was cheaper and faster than hiring engineers. So their initial launch was very successful. They got a lot of signups. They wanted to implement proper user authorization flow. And as they were integrating with Authris, the first company, there were some hiccups because the no-code platform had its quirks, so it wasn't straightforward. And I remember the founder said, hold on, we're going to throw away our beautiful prototype. We're going to hire engineers and do it properly from scratch. And so they did that. They took quite some time to actually get started and move on. Now, the second company, they didn't wait. They were like, go, go, go. We have traction. We have something that works already. Let's just keep adding things to it. And they hired some contractors to handle the integration. They were pretty quick, done. Fast forward several months, just looking from their bills. The first company was much slower to start, but then they kept adding users at a steady pace, constantly scaling. The second company, they had an initial peak, and then they plateaued. And eventually, they went out of business. So when we think about time, we frequently consider the urgency. How quickly do we need this problem solved? But sometimes it is more helpful to consider the lifetime of our solution. And yes, I said solution, not a problem. although both are relevant. Even if we know that our problem is we were going to have that problem for a very long time, our solution doesn't have to live that long. In some cases, it may be better to just do something suboptimal right now so that we can move on and then revisit later on. Even if we manage to find a perfect solution, it helps to look back at that decision and see if there are better options today. So let's look at our decision process so far and add the time component to it. So step number 1, verbalize the problem. If we can wait, we should wait. But if we are in a rush, we should just get it off the shelf or maybe use an open source, unless the problem is simple, in which case we should just build it. Otherwise, we consult the table. This is a bit clunky. I really don't like it. Let's keep refining it. People often say that time is money, so maybe we should look at that. Everyone cares about cost, even if they say they don't. And the conventional wisdom says that open source is free. Building doesn't really cost us anything, it's just time. And when we buy, we pay exactly what the vendor says on the website or in their sales call. If only. So back at that company I told you about, the one with the nightly build, we eventually came to our senses. We decided to break up the monolith, do more continuous integration, so our wonderful build tool had to go. We wanted to replace it with something industry standard. The problem was, at the time, we needed a solution right now, and we didn't have a budget. That's how important it was to our leadership. Anyway, why not use open source? The solution is ready, it's out there, it has an active community of supporters, and hey, it's free. So we went with Jenkins. And of course, we had to host it somewhere. So we had to provision a bunch of servers, install the prerequisites, all of that. We did all of that. It was great. Except Jenkins servers, being servers, had to be occasionally jiggled. Welcome to DevOps. Once in a while, a runner would hang, all the builds would fail, we had to reboot the machine. Another time, a machine would run out of memory, for whatever reason. Reboot. Then we had to deal with the software updates, install patches, sometimes versions would conflict, and all the joys of hosting. And then there was a matter of Jenkins itself. At the time, we needed some of the features that weren't implemented yet. But they were in the Jenkins roadmap, so we were optimistic. But the roadmap kept being delayed, and eventually we had to write some custom plugins for simple things like deleting old builds so they don't clog the machine. In the end, we had 2 software engineers dedicating roughly half the time to fiddling with Jenkins and not writing features for our customers, the ones that we were paid for. So, was open source free? Not for us. And that is a common pitfall that many people still today make that mistake, considering that the cost of their software is just the initial price that they pay. But if you assume that, then you're going to be bitterly disappointed, because what matters is the total cost of ownership. Let's see what goes into owning a piece of software. Well, there's this initial cost, the cost to develop it. And if we're buying, we may pay a license, although I really don't know who does that business model still. This is the part that we get for free when we use open source. So we build it, we release it, it's done, right? No, of course not. When was the last time you remember when you put a feature in a production and then it was still running, unchanged, untouched, 2 years later? Happens sometimes, but it's rare. And sometimes you find that piece of code that somehow still works after 5 years untouched and is like unearthing that ancient mythical artifact. Most of the time, you release it, you deploy it, and then inevitably someone finds a bug. So you have to change it. Or our requirements change, or we keep adding features. In other words, we maintain it. The thing with cost of maintenance is that it is hard to predict upfront, because we don't know how many bugs we have. We don't know how our future changes will evolve. And because it is difficult to predict, some people like to ignore it. Maintenance cost is what our subscription fee covers when we're buying software. It's the cost of ongoing bug fixes and the feature development, and hopefully those are the bugs and features that we care about. For open source, we get some maintenance for free from the community. Occasionally, we need to do some work ourselves, and every now and then, we end up in that situation where all our bug reports get automatically closed by a bot, and we end up forking that project. So initial cost, maintenance cost, that's not all. We still need to run the software somewhere. We need to operate it. So hosting, availability, performance, security, all the boring IT stuff has to be done. And if software is ours, we're on the hook for this. If we buy, this is what our subscription fee covers. For open source, we have to take care of this ourselves. It's on us. We have to pay for it one way or the other. So, if we were to give a rough rating how expensive each option is, here's how it would look like. When we're building, we pay for everything ourselves, and we pay the full price. We get no discounts. What's more, we pay twice, because we also incur the cost of opportunity. If we're working on solving this problem, we're not working developing features that we're paid for. That's additional cost. So building software is comparatively expensive. When we're buying, there's always some initial cost because we have to spend time to integrate the thing into our system, even if there's no upfront license fee. Now, for the vendor, for the provider of the software, the expensive cost of developing it and ongoing maintenance and operations, that gets distributed across a large number of customers and amortized over a long period of time. They get the benefit of scale. That's why it can be relatively cheap for us. We get a discount. In fact, any off-the-shelf solution is always going to be cheaper than if you were to build that exact same thing yourself, for that reason, benefits of scale. Now, for open source, the only significant cost is the cost of operation, because that is all on us. So we pay the full price, we get no discount, and we incur the cost of opportunity. So if we were to represent this more visually as a graph, this is how it may look like. And if you're looking at this and think, this doesn't look quite right, you are correct, because total cost of ownership is always a function of time. Remember the lifetime of our solution? If our solution lives for a very long time, this is how the breakdown may look like. It's the ongoing cost that matters. And this shows us that open source really isn't free, and in some cases it will be more expensive than a commercial solution. On the other hand, if our solution is only meant for the short term, well, the initial cost, that's all that matters. But if the problem is simple, we may be able to just develop it, release it, and mostly forget about it. So the cost breakdown may look like this. So when thinking about cost, we need to consider total cost of ownership, lifetime of the solution, and complexity of the problem space. Who said this was going to be straightforward? But maybe we can take our decision table from before and see if we can remove more options by removing those that are more expensive. If you really love graphs, I put a graph in a graph. So, for simple problems, for domain-specific things, it may be marginally faster and therefore cheaper to just use whatever libraries out there. On the other hand, for company-specific problems, it's the opposite. It will be faster for us to just build it. Now, for everything else, first I'm going to address the choice between buying and using open source. If our solution is going to live for any significant period of time, we know that the cost of operation is going to be significant for open source. Therefore, it's going to be more expensive. Therefore, I'm removing it. Now, before some of you start shaking your heads, I am aware of some of the more complex open source solutions where you can pay for a managed version, like Elastic or Redis. Now, those actually aren't open source. They fall under buy because they are regular commercial solutions that follow all the rules of profit that only so happen to have published the source code. And if you don't believe me, try to get your change request or bug fix merged in. So those fall under buy. They're just commercial solutions. So our options are thinning. Let's look at the domain-specific complicated problems. We know that building is going to be most expensive, so let's get rid of that. So we have only this one left. Now, buying should be cheaper because we get a discount. But it may not always be possible if it's something specific to our company. And if we have to modify the solution heavily, then that work that we're doing may actually eat all the savings. So I'm just adding another question mark here rather than removing it. So we have more clear recommendations. Let's look at our decision process so far. Verbalize our problem statement. Wait, if we can wait. Consult the table. This table, by the way, contains the options that are not only cheapest, but also fastest, because time is money after all. This is good, but sadly, there is one more thing we have to consider. Otherwise, we risk falling into another pitfall. Did I say risk? There is a lot that can go wrong when we're considering a new piece of software. We may go with an off-the-shelf solution for a long-term problem, and the vendor decides to shut it down. Or we may decide to build it in-house, but we ran out of money or maybe management changes, and we end up with a half solution full of bugs. Or we go with open source, and 1 year later, a critical security issue gets found that enables remote access to our machines, and it was there this whole time. These are all the bad things that may or may not happen in the future. We cannot know the future. So, remember this. If we're already dealing with a lot of unknowns and a lot of uncertainty, and we add the uncertain future to it, oh dear, this is where we can really stupid ourselves. But let's stay calm and let's consider how risk really impacts our decision process. Anything that can go wrong can roughly fall into one of the three categories. Waste of money, waste of time, which is almost the same as waste of money because we know that time is money, or a loss of reputation, which in the end also is a waste of money because reputation means customers, customers are money. And there are two parts to every risk. There is the impact, this is one of the three, which notice that all can be expressed in monetary terms. And then there's probability. How likely is it that the bad stuff will happen? This is usually expressed as a percentage. And only the two together will tell us how high the risk really is. So if you are considering where to get your new piece of software and the topic of risk comes up, I encourage you to take a moment, 5 minutes, not more, to briefly think about it and see if you can point to which category of loss we're talking about, and if you can roughly estimate the size of the impact, order of magnitude, are we talking millions or thousands, and see if you can reason about the probability, low, medium, high. If you can't do that, then you are not really talking about risk. You are, in fact, flailing around in the corner of ignorance, responding to your fear of the unknown. So let's look at actual ways we can de-risk a software solution. To control the risk, we really can only affect the impact or the probability, or both. Now, impact is tied to the size of the problem. The smaller the problem, lesser the impact. Probability, on the other hand, is tied to expertise. If we know what we're doing, we're less likely to make a mistake, less likely bad stuff will happen. So there are two main strategies for us to de-risk a solution at this stage, at the decision stage. One very underrated strategy is to reframe the problem. This will help us control the size of the impact. So we can split our problem into smaller bits. That way each bit may have smaller risk to begin with. So if we need to run a nightly build, we can split that into, we want to compile our modules, we want to run all our tests, we want to run all our build tasks on a schedule. And notice how every piece may end up in a different part of this table than the original problem. But if we are in this dreaded corner, we may actually not be able to break the problem down because we may not know enough. So another way to approach it is to replace the problem with another one. It's what I like telling to our engineers. Have you tried not having that problem? So if we were to say fully automate handling of our customer support emails, maybe it's good enough for our business if we just make our support staff more effective. Or maybe instead of solving that problem, we can try dissolving it. So instead of dealing with our support emails, maybe we can reduce the number of cases. See how talking about problems, not solutions, is actually beneficial. So first strategy for de-risking a solution is to reframe the problem. The second one has to do with managing the expertise. If something is risky, we should leave it to the experts. Who are the experts? Let's look at our table. If it is something specific to our company, we are the experts. We should have all the expertise in-house already. If we don't, what are we waiting for? Who's going to do that? Our competitors? Now, for everything else, the question becomes, do we trust the expertise of others, or do we need to become the experts ourselves? But remember the corner of ignorance? The thing with expertise is that it costs money, a lot of money. And it's not just one time thing, it's an ongoing investment. So if we are considering taking control of an area to become experts ourselves, it really boils down to one thing. Can we afford it? Can we sustain it as an investment? And speaking of investments, we really briefly need to talk about risk's favorite cousin, opportunity. In business, opportunity is something that has a potential to make us money, give us some sort of competitive advantage, which in the end also means more money because we'll get more market share. Or it can be something good for our reputation, which also in the end means more money because reputation is customers, customers are money. But these positive things aren't guaranteed. We need to do something to unlock them. To pursue an opportunity, we need to commit to it. And if we see a problem as an opportunity, that is, it has a chance to make us money, give us some sort of advantage, or be a good marketing piece, well then, the question is, can we? Then the high cost of doing it ourselves, of developing the expertise, basically is paid for by the opportunity. But if we cannot sustain that, our expertise, our advantage will eventually fall behind whoever in the market is currently investing in it. So, from the risk standpoint, building something ourselves carries less risk only if we can secure our permanent commitment to it. So, let's look at our decision process and add the risk component to it. Step number 1, verbalize the problem. Wait if we can wait. Then we will analyze the risk. If it is risky, we will split the problem. If it is still risky and we can afford the expertise, we will build it. Otherwise, consult the table. We are back to clunky. But all of the things that we talked about, all of the factors, actually really hinge on one question. How specific is this problem? Does it have to do with us? Is it our core business? And if we start with that in mind, we can convert all of this into a fairly straightforward decision chart. Let's try that. First, our prerequisite. Can we verbalize our problem? If we cannot, well, we're doing something wrong. Back to the drawing board. Think about it some more. Come back later. If we can, well, is it our core business? If it is, will it make us money? Yes, we're building it. No questions, no shortcuts. If it won't make us money, then we're talking about necessary cost. Can we manage the cost? Let's try to split the problem. If we can split the problem, we should split it, repeat for every little piece. If we cannot split the problem, well, then we're just building it. What if it is not our core business? Can we find a solution on the internet? If we cannot, maybe it is an opportunity. If it is not an opportunity, and we have searched, something's wrong. Probably we're either talking about the problem wrong, or maybe this is not a real problem. Definitely it's not worth solving. We don't even think it's worth solving. If it is an opportunity, then the question becomes, do we have the resources to actually commit to it, to claim that opportunity? If yes, we're just building it. Yay, profit. If we do not have the resources right now, then maybe we can wait. If we can, we wait. Revisit later. If we cannot, then it is a matter of necessary cost. So we manage the cost by trying to split the problem. You know the rest. So what if we can actually find a solution on the internet and it's not something that's a core business? Well, then it's fairly straightforward. How complex is the problem space? If it is simple, we go with open source. If it is complex, we go with a commercial solution. If it is in between, then the question becomes, do we want to support it? Do we want to run it? If yes, open source. If not, buy it. So, there are a lot of steps, but it also contains all of the important factors that companies typically consider in that decision process. And we have fairly clear outcomes at the end. Can this be simpler? Yes, it can. 2 questions. Is it our core business? Do we have the resources to operate it? We are losing some nuance here, but sometimes we don't need to go that deep. So there you go. All your answers in a single chart. Thank you so much. If you want, for whatever reasons, the charts or the slides, here is the link. If you have questions, I'm staying till the end of the day. Feel free to talk to me. Also, if you want to argue about something I said, please come find me. Let's argue. Thank you so much.